Good morning. Let's go ahead and jump right into it since I've got a lot of stuff I want to cover in the relatively short amount of time we've got this morning. Let me start by introducing myself. My name is Scott Kofod. I'm principal scientist with Cargill de-icing technology. I've been with Cargill now for 22 years working in research and development. And a large part of my work has been around trying to better understand the basic chemistry and the basic science behind how de-icing chemicals work. And the hope is that this understanding will help us to better formulate improved products in the future and also to better use the products that we currently have available to us. And so that's what I want to talk about this morning. I want to spend a little bit of time talking about the science of de-icers, and in particular, I want to talk about liquid de-icers this morning. Arguably, the single most important change in the way that we use chemical de-icers over the past 20 years has been the increasing use of liquids. Liquid use has skyrocketed over the past 15 years. Until now, it's more or less standard operating procedure for winter maintenance. So let's, for openers, just remind ourselves the basics behind how we use liquids and why we use liquids. So what is a liquid de-icer in the first place? Well, a liquid de-icer is nothing more than a dry de-icer that we've dissolved in water. So you take rock salt, for example, you add water, mix it up to make a brine. Now you've got a liquid de-icer. What is special about liquid de-icers? Why would we want to use them? Because if you think about it for a moment, a very obvious intuitive reason may occur to you as why you would not want to use them. And that's because they are diluted. I mean, the whole idea of a liquid de-icer is you've diluted it with water. And the more water you add to a chemical, the less ice melting effectiveness it's going to have. All of the water you add to salt to make a brine is that much ice it can no longer melt. So why on earth would we ever want to use a diluted product? Well, the answer is efficiency. We give up some ice melting capacity in exchange for increased application efficiency. And we don't want to take that for granted. We always want to use the least amount of chemical possible to get the job done when we're de-icing, both because it will help us to reduce total chemical costs and just as importantly to minimize our impact on the environment. And liquid de-icers are very effective tools for minimizing application rates. We do this primarily in two ways that you're probably all familiar with. One is anti-icing. In anti-icing, of course, we apply the de-icer to the pavement before the storm occurs. And anti-icing is always the ultimate in efficient de-icer application. Now, of course, Mother Nature will not always cooperate with us. Sometimes we can't get ahead of the storm, or the storm goes on for a long period of time. And a fact of life is we're often going to have accumulation of snow and snowpack on the road we've got to deal with and apply salt directly to. So we're going to have to do that a lot of the time, but it's inherently inefficient because we end up having to burn through a bunch of the salt's ice melting power just to melt through that layer of snow and get down to the pavement. And it's at the pavement surface where all the important work of the de-icer is really going on. We do not rely on chemicals to try and bulk melt all that snow and ice off the road. We don't put down anywhere near enough salt to do that. To give you a feel for that, for a 1-inch snowfall, a typical highway salt application rate is only enough salt to melt maybe 0.1% of all that snow and ice. So we really rely on plow action, of course, to remove the bulk of the snow accumulation from the road. The de-icer serves just to make the pavement safe again. So the de-icer's function is to break or inhibit the bond between the snow and ice in the pavement and to melt any residual snow or ice that's left and restore it to a safe friction level. And liquids are an ideal carrier to do that because they enable us to spread out and apply a relatively small amount of chemical directly on the pavement surface rather than having to have a big chunk here and a big chunk there and kind of have to waste a bunch of ice melting juice by burning through a snow layer. So anti-icing is one important way we reduce application rates. The other is through pre-wetting. In pre-wetting, we blend salt with a liquid before we apply it to the road, and many years of experience have showed us that there are a number of advantages to that. The wet salt sticks to the pavement better, so there's less loss of salt by bounce and scatter off the road. The wet salt, the ice melting action occurs more quickly. Depending on the liquid that we use, we can get some lower temperature effectiveness. And all of these factors enable us to use lower application rates.